Alright, so this video is going to be about functions, and a function is a relation in which each of the domain means the x value, is paired with exactly one element of the range, and the range is the y value. So another way of saying it is that there is one and only one y, or output, with each x, or input. So basically, once x goes into the function, y comes out, and there's only each x is only paired with one y. I would write this little part right here in your notes. So function notation, so you're going to see this a lot in class later in the week. So y is your output, the name of the function, and then x is your input. So let's get started. Let's see which one of these relations is a function and why. So here you go. You have some ordered pairs, some points. Domain would be your x values, so 2, 3, 5, and 4. And then the y would be your range, 3, 0, 2, and 3. So each x has to pair with only one y. So for example, in this point, 2 goes with 3. 2 does not go with any other numbers. I don't see another 2 in the x spot. 3 goes with 0. I don't see another 3 in the x going to another y. 5 goes with 2. 4 goes with 3. So yeah, this is a function. Now let's determine this one. Okay, 4 is paired with 1. 5 is paired with 2. 5 is also paired with 3. 5 cannot go to 2 and 3 at the same time. That's a big no-no. That means 5 is an x that has two y's. That's bad. That's not good. So when you see an x repeating, that means it's not a function. 5 can't be with 2 and 3 at the same time. It's not functional. So let's see if this is the function. 1 goes with 3. Do I see a 1 going to any other y? No. 2 goes with 3. Do I see a 2 going to any other y? No. 3 goes with 3. Do I see a 3 going with any other y? No. So this is going to be a function. You're looking at the x values. Those are the values that matter. Each x is only going with one y. It doesn't matter if the y values repeat. You're concerned with the domain, the x. So now you're going to have to deal with it mapping. So you're going to look at the map, and you're going to say, okay, 1 is paired with 6, 2 is paired to 2, 3 is paired to 4, 4 is paired to 8, and 5 is paired to 10. So over here, the green, that's your x's, that's your domain. And over here in the blue, that's your range, that's your y's. So each x is only going to one y. So it is a function. Ta-da! So they use all the x's are only going to one y. It meets all the conditions, it's a function. So here 1 is going to 4, 4 is going to 4, 2 is going to 4, 5 is going to 4, 3 is going to 4. So what you're looking at is 1 goes to 4. Does 1 go to any other y? No. 2 is going to 4. Does 2 go to any other y? No. 3 goes to 4. Does 3 go to any other y? No. 4 goes to 4. Does 4 go to any other y? No. 5 goes to 4. Does 5 go to any other y? No. Your x's aren't repeating. It's okay if they all go to the same y. So that is a function. So there's a lot of different ways you can think about this. Think about your grades. Okay. So if student 1 got a grade of 2 on a test, they can't get a grade of anything else. If student 2 got a grade of 10, they can't get a grade other than 10. If student 3 got an 8, their grade is an 8. They can't have another grade. If student 4 got a 6, that's their, and if student 5 got a 4, that's their grade. What if student 2 had a grade of a 4 and a 10? That'd be impossible, right? So this would not be a function. And that's because 2 is trying to get a grade of 4 and 10. Doesn't work. So what about this relation? Is it a function? No, because 3 is an x or a domain, and it needs to go to some kind of y or range, and it doesn't. So you're not using your x's. Okay, is this a relation? Yeah, 1 goes to 6, 2 goes to 2, 3 goes to 2, 4 goes to 4, 5 goes to 5. There's no x that's going to more than one y. Okay, which one would be a function? You have 2 going to A, 2 going to B, 2 going to C. It's like saying student number 2 has an A, B, and C in my class. That doesn't work. What if student A has a 2, student B has a 2, and student C has a 2? They can all have 2s, they can all have the same grade. So b would be the function. All right, same thing here if their functions are on a table. 0 goes to 5, 1 goes to 11, 2 goes to 16, 3 to 21, 4 to 26. 0 only goes to 5. 0 does not go to any other number. 1 only goes to 11, 1 does not go to any other number. 2 goes to 16, 2 does not go with any other number. Therefore, it's going to be a table because each x only has one y. Well, what about now? 1 goes to 70, 1 goes to 75. You can't have this kid making a 70 and a 75 in the class. So it's not going to be a function. Each x does not go to one y. Number 1 and the x goes to 70 and 75. Not a function. Okay, so the vertical line test, pretty easy. So you're going to draw a vertical line on the graph, and if it goes through more than one point on the graph, it's not a function. So here you go. Is that a function? You see the black lines? They're vertical lines. Each vertical line only touches the red line one time. Each vertical line. Same here. Each vertical line only touches one time. What about here with this red circle? It's not a function because you notice it passes right here and right here. The vertical black line passes through twice. What you're going to do is you're going to use your pencil as a vertical line to see if it's a function. So here we go. Is that a vertical line test? Is that red horizontal line a function? Yes. What about right here? Well, this red line is a vertical line. So if I put a vertical line, it's going to go through more than once. And then here, not a function. It hits twice. Then here, it's a function. It's not linear. It's not a line. It's not a straight line, but it's a function. Remember, you can do your pencil on the test, and that's your way of drawing a vertical line. So is this a function? Yes. Draw your vertical lines. It's only going to hit once. Okay, the last thing you're going to do is when you're given a function, if it says you're going to have to solve. So given f of x is equal to 3 times x minus 2, you're going to find f of 3. What that means is it's a fancy way of saying, hey, let x be 3 and solve. So guess what? You get where the x is, you put a 3. 3 times 3 is 9 minus 2. Bam, your answer is 7. What about if I put in negative 2 as x? Well, let's just do that. 3 times negative 2 is negative 6, minus 2 is negative 8. There you go. So here, looks crazy. Look, h is negative 3. That means where the z is, you're going to put the negative 3. It means negative 3 squared minus 4 times negative 3 plus 9. So negative 3 squared is positive 9 minus 4 times negative 3. So that'd be a positive 9 plus 12 plus 9, which would be 30. So if h of negative 3 is 30, the function of h, when h, given function h, when z is negative 3, it's going to be 30. So right here, put a 4 in. Wherever you see x, put a 4. 4 squared is 16, minus 2 would be 14. Given f of x, 2x plus 1, find negative 4. Okay. F of 3 minus f of 1. So first you're going to put x as 3. Then you're going to put x as 1. Oh. Okay, sorry. That video ended. Okay, so you're going to put 3 in there. 2 times 3 is 6, plus 1 would be 7. Put a 1 in there. 2 times 1 is 2, plus 1 is 3. Then 7 minus 3 is 4. Negative 4 times 4 is negative 16. Okay, don't forget to do the form.